Here is a breakdown of the compound interest formula, manipulating it to make every variable the subject. Okay, and then we are going to firstly start with making P the subject of the formula. We are going to use inverse operations to do that. Ne? So when we look at this formula, we can see that P is this guy here, which we want to make the subject, and is being multiplied by this bracket. So to isolate P, it's very easy. The inverse operation of multiplication is division. So I'm going to firstly write the formula, which is P 1 plus I to the power of n. And then to remove that bracket that multiplies the P, we're going to remove it by the inverse operation of multiply, which is divide. So we divide both sides by 1 plus I to the power of n. And this side, they cancel each other. And we can see that we're left with P equals to A 1 plus I to the power of n. And P is now finally isolated. On the second question, we want to isolate n. Okay, let's do that. Let me just erase this. So number 2, they say we must isolate n. So to isolate n, let's start, ladies and gents. We always write our formula first. Plus I to the power of n. And then, obviously, n is attached to this bracket here as the exponent. So P must move first. And we can see that P is multiplying on the right. So on the left, it must be dividing. So on the left, I'm going to transpose the P by division. So I have A over P equals to 1 plus I all to the power of n. Okay, and then we're going to introduce logs on both sides. So we're going to have log A over P is equals to log 1 plus I to the power of n. Always when you want to make an exponent the subject, you introduce logs. And we know the rule that says log A over P is equals to the exponent can become the new coefficient. So it multiplies with whatever is here. And whatever is there is 1. So 1 times n is just n. So we have n log 1 plus I. And then we can see that we're going to divide both sides by log 1 plus I to isolate the n. So log 1 plus I, both sides, and then this cancels that. Therefore, n will be log A over P divided by log 1 plus I. And that is your final formula. If you want to, you can write it this way. You can say log base 1 plus I and then A over P there. So either way, it's fine. And that's how we make the exponent n the subject of the formula. Now, let's go on and make the last one, I, the subject of the formula. Ne? So that is number 3. Number 3, let's write the formula first. We have A equals to 1 plus I to the power of n. Okay, and then obviously let's highlight what we need to isolate. I always highlight. I need to isolate this guy. And it's logged inside the brackets. So the P must move first. And then the n moves secondly so that we can open the bracket. And we can see that P is multiplying, so it must divide on the left. So it's A over P equals to 1 plus I to the power of n. To remove an exponent, we remove it by the root because the inverse operation of an exponent is root. So we root n both sides. So on the left, we're going to have n root A over P. On the right, the root and the nth root and the n cancel. So you're left with 1 plus I. Then you can see, ladies and gents, to isolate I, you need to transpose the 1 to the left. So it will become minus 1 equals to I. Okay, and remember, when you solve for I, you always have to multiply the final answer by 100. Okay? All right. And then that's it, ladies and gentlemen, for this formula, right? And you would follow the same rules for this, for a equals to p 1 minus I to the power of n. The only difference is this one is depreciation with a minus, this one is for appreciation, but the rules of making the subject of the formula are exactly the same. Thank you very much.